All right. Hi, everybody. Today is Wednesday, February 28th. We are behind schedule. So today we will talk about 8.4. So which means I will need to postpone like the homework and these this schedule. I already postponed the due dates of the homework and quiz. Yes. hmm So the schedule I printed out for you at the beginning of the semester will not be the same as this one. So look at the online one is like more accurate. Okay. So last time you had a quiz. So I graded your quiz. Now let's look at the quiz solution and quiz mistake. hmm Okay, so the first problem, by the way, exam 2 will be about chapter 8. So chapter 8 has 8.1, 8.2, 8.3, 8.4, and the two sessions of chapter 9. So I just give you the chapter 9. So your exam 2 also covers 9.1 and 9.2. And then your exam 3 is the remaining of chapter 9. And I can tell you, the remaining of chapter 9 is hard. So your exam 3 is hard. That's why I decided to break it. So the first two sessions is now with exam 2. Okay. So your exam 3, it won't be hard and a lot. Okay. It's only hard, but not a lot. Okay. So let's see. So chapter 8, it's always good to look at the concept map. Mhm. Because concept map like help us to see what we're gonna learn in this chapter, what any relation between them, and the methods. Okay, so 8.1 we talk about integration by parts. So it's only for two type of problems. If you see power function times exponential function, then you let u be the power function, and then dv be the exponential function. The second type is power function times natural log. Then you let u be the natural log, and then the remaining to be the dv. It's only those two type of functions. Okay, so if you see an integral is not any of this type, then you should not use integration by parts. Okay, you either use u substitution if you see a composite function, or there is a way you can simplify. Maybe you distribute the term and simplify the x power, or like in your exam, you split the each terms of the numerator divided by the denominator, and then you can use the basic rule for integration. The three basic rules, remember? Power function, exponential function, and 1 over x. Okay. So that's why in your quiz, the first problem, you see power function times exponential function. So let u be the power function, 5x plus 3. And then the remaining is the dv. So dv is the exponential function. Then du, the derivative is 5 dx. Make sure you have the dx because it's differential form. Both sides you should have the differential. Remember, two kids on the seesaw, you need differential on both sides. And so here, the u we want to differentiate, the dv we want to integrate. So that's why it's divided by 6. And do you change the exponent? Do you change the exponent to be 6x minus 1 or 5x? No, don't change the exponents. Divided by 6. Do you divide it by x? No, just the coefficient of x divided by 6.
So if we break this down, just so I'm clear, it
Mhm.
would be e6x over 6, and then you could pull the 6 out. correct?
Yes,
The 1 over 6.
exactly.
Okay.
Right. So, yeah, integral uv minus integral v du. Everybody familiar with the formula? Good. So that's why the u, make sure you put a parentheses there. Because if you don't put a parentheses, it means only 3 is multiplying by this side. You're not multiplying the final x by this.
Mm.
So you need the parentheses here. And then minus integral v du. And now you can put a constant, like constant multiple 5/6 in front. And the integral of e to the 6x is e to the 6x over 6. And then 6 times 6 is 36.
Oh, I know why it lost half a point.
Okay. Excuse me. So, and then the second problem is to find the volume. Okay, so this is the 8.2, right? We have two applications. Find the volume and the average value. Volume. Remember, you draw the picture, and then because I always ask you to rotate about the x-axis, you always cut the rectangle vertically, and you have the x. So, and you draw what happened to the endpoints when you rotate about the axis. You get one circle, and it's disk metric. So sum of the volume of each slice. Each slice, the area base is pi r squared times height is dx, right? That's volume of a cylinder. And if you get any less, it's pi parentheses big R squared minus small r squared. Okay, and in this problem, I asked you to find the volume and of this under this function. So you draw a little rectangle, you rotate, and this is the formula. We're looking for the volume, not the area. So therefore pi, and then x from 0 to 1, the function square. That's 81. X squared is x to the 4th. Then we divide it by 5. Add 1 to the x squared divided by 5. So your answer is 81 pi over 5. So this is one application. We also learned the other application is you find the average value. The average value is that you find the area under the curve and divide it by the length of the interval. That's the average value.
No.
So when you read a problem in the exam, be careful, okay? So read the problem carefully. Now let's look at the mistakes.
I did not.
So let's see.
You can do
Quiz
mine.
2.
That one is around.
Quiz 2. Again, we're brothers, sisters, we're family. Okay, so it's okay to make mistakes. Sometimes I make mistakes too. So we just learn from it, and in the exam, we'll avoid this mistake. So here, parentheses. Okay, everybody say parentheses.
Parentheses.
Parentheses is our baby. Don't forget your baby in the mall. You have that feeling? Okay. All right. So parentheses. And then here, C. Don't forget your cell phone. Your cell phone very important, right? For indefinite integral, you need your cell phone. And here, 81. Yes, 81. 81. 81.
I must have been drinking on those.
So that's why this is so small mistake. So I used to try to point to.
At least you knew that you knew what I meant.
Yeah, I knew. And this one, the setup, not average value, the volume. So pi and then r squared. Okay, so the setup. And here. Oh, so one term. That's why 9 squared is 81, and then x squared is x to the 4. We don't have this. If you have 9x plus 2 squared, okay, if you have plus 2 here, then you get, or minus 2 here, then you get this. But you don't have this bit, right? So only one term, no, not 3 terms. And it's x to the 4. We didn't learn the function where x is in the base and in the exponent. We didn't learn that. In the regular calc sequence, we do learn that. and it requires different methods for that. So when x is in both of the base and the exponents. So we only cover either x is in the exponents or x is in the base, but the exponent is constant. Okay, so yeah. But in the regular calc sequence, we do cover like trig function, and we can have something like crazy like that. Okay, so where x is in the exponent and in the base. But in our class, only focus on the x is either in the exponent or in the base. Okay, that's the mistake. Any questions? So it's okay to make mistakes. I hope in the exams you can avoid making these errors and improve. Okay. By the way, so spring break is coming. It's about the time to enter midterm grades. So please improve your homework scores and the self-assessment scores. That hopefully those scores can raise your exam grade a little bit. Then you get a higher grade. Okay, so let's continue. Okay, so last time we talked about the income stream, right, everybody? Hey, where is my notes? Okay, let me see. My notes, is it here? So 8.3. Oh, did I forgot to save my notes? Where's my notes? Is it here? Did I forgot to save my notes? Oh no! Oh no! Okay. So it's okay. Then maybe I can look at the notes with answers. Yeah, that's the good thing about the notes with answers. Okay. Yeah, because we're behind schedules. So do you mind I just go over this problem with the notes with you so okay we can catch up a little bit? Okay, so last time we did part A, right? Did we do part A? Sure. And we find the present values, and then we find the future values is the present values times e to the RT. And the R is 10%, which is 0.1, and times T is 5. Okay, so part B. Oh, your part B is, let's see. Your part B is the present value at the 5%. The 5%, the only difference is if this is 5%, you change the R to be 0.05. Is that okay, everybody? You change the R to 0.05 and then everything else remains the same. And it only asks you to find the present value, it kind of stops here. Is that okay, everybody? So yeah, part B is like that. And then part C, if the money flow starts at a rate of 1,000 per year and decrease exponentially. So our old problem was 1,000 per year and increase exponentially. So that's why our function, the income stream function f of t, is 1,000 times e to the RT because it's increasing. But now if it decreases exponentially, if the R is negative because it decreases, right? So then the F is 1,000 e to the negative 0.02t. Is that okay, everybody? So like the process is similar to what we did before, but now instead of positive 0.02t, it becomes negative 0.02t. So therefore here it was negative 0.08t, but now negative 0.02t and minus 0.1t becomes negative 0.12t. Is that okay, everybody? So in the exam, read the problem carefully. They increase or they decrease. Okay, your income stream setup will be different. And then similar, we integrate, so it's e to the that divided by the coefficient of t, and we evaluate from 5 to 0. E to the 0 is 1. And this is the number we get. And then the future value is the present value multiplied by e to the RT. And by the way, the 2% and the 10%, they are different things. Okay? The 2% is just about like how the income stream change every year. So every year your income stream are different. But it affects the F of T. But then the R is like after the money in. So imagine if I draw the picture. So it's like this is the machine, okay, it's running and we can earn more money. And then you have the income stream. So the 2% only affects this income stream. So after you income here, then this amount is gonna be has the R, which is 10%. It changed with this R. Okay, everybody? So yes, those 2% annual interest rates are different things. Okay, so this is the last example of 8.3. Any questions? All good? Yes. Oh, did my alarm ring? And then I just turn it off?
Yeah.
Thank you. Yeah. Thank you. Okay. Oh, and today I give out the chapter 8. All right. So let's continue on 8.4. Okay. So 8.4, improper integrals, infinite intervals. So now consider infinite region as that lies under the curve 1 over x squared. You know, 1 over x squared looks like this, right? When x is getting bigger, 1 over x squared goes to 0. Okay. So you might think that's because this region is infinite in extent. The area must be infinite. However, this is not true. So if we compute the area function, so imagine A of t is the area under the curve from 1 to t. Okay, we have a parameter t here. And how do we calculate the area under the function from 1 to t? Well, you set the integral from 1 to t of the function 1 over x squared dx. And how do you integrate? You need to make it to the standard form first, right? X to the negative 2, and then how you integrate? Power rule, add 1 to the exponent and divided by the new exponent. Yes, everybody? And then that's why it's minus 1 over x. Evaluate from 1 to t. This means we plug in t first. If you plug in t, you get minus 1 over t. Yes. And minus, we plug in 1. You see, when I plug in 1, I get negative 1 over 1. It's 1. Therefore, minus become positive. I get 1 minus 1 over t. Now, let the t varies. The t is moving. It moves to infinity. Look at this guy. When t goes to infinity, 1 over infinity goes to 0. Therefore, this area goes to 1. Okay, everybody? So even though we have an infinite interval, because the function is getting smaller, the area is actually finite. Okay? It's like that story, we have ants, right? Okay, it's walking. The first day, it walked 1 feet. And then the second day, it walked half feet. And then the third day, it walked 1/4 feet. Guess what? The next day, it walked 1 over 8 feet. Let's assume the ants live forever. It walked closer to the 2 feet, but unfortunately, can it ever touch the 2 feet? No. It's just walking closer to 2 feet. So even though you add a lot of numbers, You add infinitely many numbers together, but your answer could be still finite. So don't think, oh, I'm integrate infinitely many things. Like the interval is infinite, then my answer should be infinite. It's not necessary. Okay, even though you add infinitely many things, your answer could be finite. Okay, so yeah, and here if you let t be 2, then your area is 1/2. You let t be 1/3, let t be 3, your area is 2/3. So when your t increases, then your area goes to 1. Okay, everybody? So definition of improper integral over infinite intervals. So improper, what is the improper value? The infinity is the improper value. Yeah. So you have a and infinity. This is called the limit of integration. So you can have your b goes to infinity. So you say limit. Okay, replace the infinity by b, and you say limit b goes to infinity. Let me check because I'm afraid it does not log me out. Because yesterday I was on the recording and logged me out, and I didn't know at the end I closed my recording. I just saw I was logged out. Okay. All right. So this is a picture. So we have a and then to infinity, which is this area. How about the left limit of integration goes to minus infinity? So you also replace it by a letter a, and you put the limit a goes to minus infinity. Because infinity or minus infinity, they're not numbered. You cannot plug in. It's like a process. You have a sequence of number approaching it. That's why we need to do that. And how about we have both infinity? Okay, then you can cut it into pieces. Let's say c is any point in the middle. Okay, so it's a limit a to c, a goes to minus infinity, plus the limit c to b, and b goes to infinity. Okay, and in each case, if the limit exists, this improper integral is said to converge. If the limit does not exist, so it might be infinity or minus infinity, then we say that improper integral diverges. Okay, everybody okay with the definition? Now let's solve problems. Okay, let's see. So, okay, evaluate the. Oh, sorry. Every time I get sick, it would take 1 week to heal. Okay, so first of all, we see which problem is the improper value. The infinity is the improper value. We replace it by t. Now we have the integral from 2 to t of 1 over x dx. Everybody okay with that? So you look, which value is improper? Oh, infinity is improper. So replace it by t, and we put a limit. T goes to infinity. So this is what you need to do for improper integral. In the exam, I will need to see the limits. Otherwise, 1 point will be off. Okay? So now continue. What is the integral of 1 over x? What's the integral? Ln of absolute value of x. Evaluate from 2 to t. Yes, everybody? And now we see is limit t goes to infinity. Ln, we plug in t first. Minus ln, we plug in 2. Right? So we get a function of t. But natural log of x, a pass through 1, 0, and when t goes to infinity, the ln of t will go to infinity. So you get infinity and minus ln 2, which is infinity. Okay, everybody? If you get the integral is infinity, then you say the integral diverges. Okay, so the integral diverges. If you get the integral is a finite number, then we say the integral converges to that number. Is that clear, everybody? So you see, this is a good example. You know, the 1 over x squared look like that, but the area is actually converged to 1. 1 over x looks like this. Okay, also looks like this. But actually this guy, this area is infinity. So it really depends on the function, the power in the denominator. Okay. Any questions about example 1? All good. All right, let's increase difficulties. Okay, let's look at this guy. All right, so let's rewrite it as y, and it's 11, and is, can I pull out the 11 in front? Yeah, and then I have 1 over, look at this. This is 3 ln x plus 5 to the what power? Exactly. And then do you see this x? So it's in the denominator, right? It's like this guy, this function, times 1 over x dx. And do you remember you see something like this in the exam? Because the 1 over x dx is kind of like the derivative of this. So we use u substitution. Did you remember? U substitution. This is composite function. And so we let u be, okay, so we let u be 3 ln x plus 5. That's the inner function. Right, everybody? And what is du? Yeah, 3 over x dx. Yes, everybody? Okay, look at this. My problem, I have 1 over x dx. That is how many du? 3 du or 1 over? Yeah, 1 over 3 du. Yes, everybody? So here I would like to, because the integral is harder, like not as simple as before. So for a harder problem, I would like to compute the indefinite integral. And then after I get the indefinite integral, the answer, I plug in the bounds at the last step. So I don't need to carry the bounds every step when I write it. So for a harder problem, you can compute the indefinite integral first. Okay, so then we have 11. Let's do indefinite integral. Then we get 1 over, do you see that's u to the 7 half? Right, everybody? This is u. This is u, and this is what? 1 over 3 du. 1 over 3 du. So we express everything in terms of u. Is everybody okay with that? Okay. Can we pull out the 1/3? Yes. So 11/3. And this is u to the what power? Negative 7 half. So every time when you want to integrate a power function, you want to make it to the standard form. Yes. If it's in the denominator, make it in the numerator and have a negative exponent. Okay, so how do we integrate? U to the to be the 5 over 2. Yeah, when we add 1. So over negative 5 over 2. But what do you do to the 2? Yeah, move it upstairs. Is that okay, everybody? And plus c. So this is the indefinite integral. Let's simplify it. I got what? Numerator. What's 2 times 11? 22. And then 5 times 3? 15. And this is u. What is u in terms of x? Yeah, 3 ln x plus 5 to the negative 5 over 2 plus c. Is that okay, everybody? Yes, everybody? And now, let's compute the definite integral. Is limit, the improper value is the infinity. So we say t goes to infinity, e to t of, can I just put that for the function? Okay, is gonna be the limit t goes to infinity, and we have negative 22 over 15. 3 ln x plus 5 to the negative 5 over 2. Evaluate from t to e to t. After we get the definite integral. Yes, indefinite integral. And then we can plug in the limits of integrations. All right, let's see. This is the limit. T goes to infinity. We plug in t first. So minus 22 over 15. We plug in t, but I want to move this thing down. So you know this thing is actually in the denominator. Okay. Because it's negative exponents. It means this factor is actually in the denominator. It's really, really important whether this guy is a numerator or denominator. Because the next step, you're gonna imagine what happens when t goes to infinity. If this guy is in the numerator, then this fraction will go to infinity. But if this guy is in the denominator, you have something over infinity. This guy will go to 0. Okay? That's why you want to, negative exponent is in the denominator. And now we plug in e. So, and then we have 3 ln e plus 5 to the 5 half. Is that okay, everybody? We plug in e. Right, so we plug in e. We have 3 ln e plus 5 to the 5 half in the denominator. Negative exponent means this is the denominator.
Is that another fraction?
Yeah, another fraction. So these times this. Because 1 over x to the a is x to the minus a, right? Mm-hmm. So yeah, how do we get negative? It was downstairs, but because we want to integrate, we bring it upstairs. We get a negative exponent. Then we're able to integrate using the power rule. Mm-hmm. But at this point, when we try to plug in the numbers, we know negative exponents, it means this drive factor is actually in the denominator. So yeah, they're the same thing. So yeah, this guy, you can make the line longer. Yeah. Oh, is it the same fraction? Or yeah, you can make it the same, or you can put a 1 here. It's the same. Yeah. Okay. All right, so now let's see. When t goes to infinity, do you see this guy goes to 0? because the denominator goes to infinity. And what's ln e? 1, right? So ln e to the x, ln and e, they cancel, you get x. That's why ln e is like ln e to the 1, you get 1. Therefore, here you get 0 plus this number is 22 over 15. And then what is 3 plus 5? 8. So 8 to the 5 half. This is the final answer. Okay. So this problem, 8. The improper integral converts to this finite number. So we can say the integral converges. And let's finish the problem. Oh, by the way, I just realized I make a mistake on my notes. Let's see. Okay. This is my mistake. You see what I did? This u to the 7 half is in the denominator. So when I write it, I forget to put a minus sign. So I got this wrong. And then I got this wrong because it should be in the denominator. Now I put it on the numerator. I got infinity. So you see, I make mistake too. Right. So be careful. It's in the denominator, and your exponent should be negative. Yeah. Okay. Any questions about part B? No? Okay. Now it's your turn. Do part C. Okay. So you can follow the step of part B and do part C. They can be in the same one. Oh, wait for me. Okay. All right. We made it.
Oh, okay. So du put it at the end. And the integral sign and the du is just symbol. When you integrate, you don't look at the section. So that's why after you integrate, integral that's it. You don't do this. It's just a notation. It's like derivative. Like for derivative of e to the x. When you take the derivative, you only look at this guy. Do you look at this at all? No, it's just a signal. It means you need to do the derivative of this function. But after you do the derivative, and you just write down the answer. Oh, this is minus 6 Oh, yes. Oh, yeah, and then the x here. Ah, that's why here you have x dx is minus 1 over 6. You divide it by that. Yeah, now you have the dx. That's why your x dx together is the minus 1 over 6.
Yeah. What do I do with the?
Oh, here we don't do integration by parts because do you see here the exponent is not just x, it's x squared. And x squared, the derivative of x squared is x.
Okay.
So here we use substitution. We don't use integration by parts. We only use integration by part when you see power function times e to the something times x.
Okay.
It has to be x. It cannot be x squared or any other function.
Okay.
Okay, so let's check our answers together. Let's see. Okay, here. So we use u substitution, and you let u be negative 3x squared. What is du? Negative 6x dx. Right? Two kids play on the seesaw. You need to see differential on both sides. And now you see we have x dx. So x dx is how many du? Negative 1/6 du. So let's calculate the indefinite integral. So we get integral. You see, this is e to the u. And then the x dx give us negative 1 over 6 du. Yes, everybody? Okay. What's integral of e to the u? E to the u plus c. And e to the u is negative 3x squared. Right? That is the indefinite integral. Now, how about our improper integral? Who's the problem value? Who's the improper value? The top one. So we place it by t and let t goes to infinity. And okay, this is not too hard. I copy it. If it's too hard, I use dot. You know what I'm saying, right? Okay. So this now is the limit t goes to infinity. Now my function, my integral is minus 1 over 6 e to the negative 3x squared. Evaluate from 0 to t. So that is, we plug in t first, minus 1 over 6 e to the negative 3t squared. Minus negative become plus 1 over 6. Do you see it's e to the 0 now? Let's see. Exponential function. Exponential function looks like this, right? This is e to the x, right? It passed through 0, 1. What does this mean? When t goes to infinity, the t squared goes to infinity. But negative 3t squared, it goes to minus infinity. Look at your function. If your x goes to minus infinity, what happens? This guy goes to 0. Did everybody see that? It goes to 0. So it goes to 0. So the final answer is 0 plus 1 over 6. So it's 1 over 6. And you get the integral converges. Is that okay, everybody? We get if the improper integral equals a number, then it converges. If it's infinity or minus infinity, then we say the integral diverges. Okay. Do you see part D and part C are very similar? It's the same function, but the bounds are different. So let's evaluate the bounds. So this is limit. Now, who is the improper value? The bottom. So t goes to minus infinity. And now we get what? The integral from t to 0, x e to the negative 3x squared dx. Right, everybody? So now let's see. This is the limit t goes to minus infinity of our the integral, the antiderivative is this, right? So plug in here, and now we evaluate from t to 0. Is that okay, everybody? And now we plug in t goes to, okay, we have limit t goes to minus infinity. And this guy, we plug in x is 0. If we plug in x is 0, we get minus 1 over 6 times e to the 0, right? And minus negative become plus 1 over 6. E to the, we plug in x is t. Yes, everybody? Okay, let's see. When t goes to minus infinity, how about t squared? T squared becomes positive infinity. The minus 3t squared goes to negative infinity. Then e to that, e to the negative 3t squared still goes to 0. Everybody? This guy still goes to 0. Therefore, the answer is minus 1 over 6. Yes, everybody? So we got the integral also converges. All right. Now, you see part C and D. Now part E. How about from minus infinity to infinity? Well, minus infinity to infinity is the same as minus infinity to 0, plus 0 to infinity, Is that okay, everybody? So what's your answer? Yeah, exactly. So minus 1 over 6 plus 1 over 6 is 0.
We'll have that one on the test, right?
Huh? And actually, you can see from here, this function is an a function. You know, if when you replace x is minus x, you get a minus sign here. But here, the minus x squared is 2x squared. This is a function. And you know, for the a function property, I don't know what the function look like. I just guess it's like it's symmetric with respect to the origin. So therefore, is this area is positive, this area is negative. They kind of cancel out. You get 0. So this is for the a function. Okay. Yeah, we only have 1 minute. Maybe we cannot finish this problem. So next class, we will finish this problem And we will go to 9.1. Okay, so 9.1 is about surface in three-dimensional space. So everybody gonna prepare to draw. You like drawing pictures, 3D pictures, surfaces? Okay, have a nice day. And yeah, keep working on your homework. If you have questions, come to ask me. Okay, I hope everybody can get perfect scores on your homework.